Today we have to discuss about electric field. First, we know the definition of electric field. If we place a charge Q here and another charge Q0 here, then the charge plus Q can repel the charge Q0 within a certain region, and this modified region is known as electric field. Or in simple sentence, we can say the definition of electric field is that it is the modified region, it is the modified region around a charge, around a charge within which the influence of the field or the influence of the charge is felt. So this is the qualitative definition of electric field. Qualitative definition of electric field. Next, come to the quantitative definition. That means we have already know that an electric field is created around this charge. But this electric field is how much stronger or weaker? How we know that? To know the effect of this electric field, we have to define another term that is known as electric field intensity. Electric field intensity, which will give the quantitative definition of field intensity, and it is just represented as E vector equal to F vector divided by Q naught. That means Q naught is the test charge, the charge placed here, and we are taking this charge as unit positive because it will not affect the position of the charge. So since force is here and electric field has a particular direction along the direction of the test charge, so it is a vector quantity. Electric field intensity is a vector quantity. Then we have to know the unit of that electric field intensity. SI unit is, if we want to write the SI unit, F, the unit of the force is Newton and charge we know Coulomb. So SI unit is Newton per Coulomb, and in CGS unit, CGS we know two types of the systems are there. In CGS, EMU and ESU are there. In CGS, ESU, dyne per stat coulomb, and in CGS, EMU, dyne per arc coulomb. So this is all about the electric field intensity, which define how much the field is stronger and weaker. Next, come to another factor that is known as electric lines of force. We have to discuss here about electric lines of force. Electric lines of force. Electric lines of force is nothing but an imaginary line or the path traveled by the test charge within the electric field if it is free to do so. Suppose this is an electric field, this region is an electric field, and within this region we have to take a test charge q0, and the region that means the path along which q0 traveled, the path along which q0 traveled, that is known as lines of forces. And we can say that the electric field intensity can give both the magnitude as well as the direction of electric field intensity. Now we have to discuss various properties of these electric lines of force. Properties of electric lines of force. Properties of electric lines of force. First thing we know that it is just the imaginary path traveled by the test charge or traveled by the charge within the electric field. So first property, if we want to discuss, that means we are putting a charge plus q here, then the lines of forces are just move away from plus q. That means diverging outward. How it is possible? We have to see. If plus q charge is here and we just put a test charge q0 here, this plus q charge just repel the charge q0 outward. So the lines of forces from plus q charge goes outward. And if we place a minus q charge here, then the lines of forces are just moving towards the negative charge. The lines of forces are moving towards the negative charge. And if a combination of charges are there, that means minus q and plus q charges are combinedly placed here, then the lines of forces are just the curved lines. It move away from positive charge and move towards the negative charge. Like that we can represent it. Moves away from the positive charge and move towards the negative charge. So in the first definition we can say electric lines of forces are the imaginary lines which may be straight line or curved line. It can be represented by straight lines or curved lines. Second property is that two lines of forces never intersect each other. Two lines of forces, two lines of forces are never intersect each other. Never intersect each other. If they intersect, then what happens? We have to discuss. Suppose here is one lines of force, here is another lines of force, and they just intersect at this given point A. Then we know the tangent. Actually we have to discuss about another property, that if along the curve path we have to draw a tangent, that tangent will give the direction of the electric field intensity. Suppose this is the curved line, this is the lines of force. If we have to plot a tangent here, if we plot a tangent here, then the tangent will give the direction of the electric field intensity, and the number of the lines of forces gives The number of the lines of forces gives the strength of the electric field. So when two lines of forces intersect each other, then at a common point there is the probability of two direction of the same electric field intensity, which is impossible. Therefore, two lines of forces never intersect each other. And the next property we have discussed here, that the the tangent the tangent drawn on the lines of force on the lines of force represent the direction of represent the direction of electric field represent the direction of electric field, and the number of lines of forces the number of lines of forces number of lines of forces gives the strength of the electric field. Strength of the electric field. Strength of the electric field. Next property, what we have to discuss, that lines of forces do not pass through a conductor. Why they will not pass through a conductor? Because inside the conductor there is no electric field intensity. Since no electric field is there inside a conductor, so lines of forces cannot pass through the conductor. And next one is, if we take a spherical conductor, the lines of forces always move normally. However, inside that depend upon the nature of the charge, but if we place a spherical conductor, the lines of forces always perpendicular to the surface. And next, 4 pi number of 4 pi number of lines of forces can plot due to a point charge. Number of lines of forces can possible due to a point charge. Can possible due to a point charge. So this is all about your electric lines of forces.